Alright, so this is the final video on the graphing calculator exercise for analysis 2, where we show you how you could use the TI-83 or 84 in order to solve these different problems. So now we're looking at problem 3, which is all about solving equations using the graph. So I'm specifically asking for us to solve the equation 5 equals x squared cosine x natural log x, where x is in the interval from 1 to 8, not including 1 and 8. Okay, so there's two ways I ask you to find an intersection function and the zero function. To be quite honest, I really think using the zero function, what I'm going to show you in 3b, is the most important way. It's the way that I would solve complicated equations where you need a calculator, but I'll show you both ways. Different people have different preferences. Okay, so that's what we're going to do. So first of all, just to explain, kind of going to guide the whole discussion, first of all, we have to believe in this, right? This was the original equation we had. If you subtract 5 from both sides, you would end up with 0 equals x squared cosine x natural log of x. Of course, I forgot, there it is, to subtract the 5. Okay, so in the intersection, to give you the general idea of what we're going to do, when we use intersection, what we're going to do is we're going to graph y equals x squared cosine x natural log x, y equals 5, find the intersection point, and the x coordinate that, of the intersection point would be the x that would be the solution to both of these equations. Okay? In the zero function, what I'm going to do is I'm going to graph x squared cosine x natural log x minus 5, and if I graph y equals this function, and I just look for the zeros between 1 and 8, those would be my answers. Okay? So that's what we're going to do in both cases, so you kind of know what's happening here. Okay, so I'm going to go to my calculator, and once again, what I said first is I'm going to solve using intersection. So I have y1 x squared times cosine x times natural log x. If you remember, in the equation, we wanted it to equal 5. So in y2, I'm going to make a 5. And what we're going to do is figure out where do these two graphs cross, because whatever the x value is where these two curves cross has to be the x value that makes both of these things equal, kind of by definition. So I'm going to graph, I'll graph, let's see what happens. So I graph, this window, we really only care about the intersection point from 1 to 8, so let me just change the window a smidge so we're a little bit closer. 0 to 9 is fine. Way too much with the y min and y max, so I'll just put, let's just go -10 for y min and 10 for y max, just for the sake of this. Now I click the graph. See, it first graphs y1, and then it graphs y2. Now you could see there's really two different points. There's two different points where we have an intersection point. So they're both within 1 and 8, so they're actually both going to be solutions. I'll just find one solution, and you should be able to figure out the other solution as well. Okay, so if I go to second calc, you could see the intersect function. Okay, so same place where we had the zeros, minimums, maximums, a very important kind of menu of options. So I press enter, I get intersect. So the first thing it asked is the first curve. Just so you know, if you press left or right, it's going to go along the curve. If you press up or down, it's going to choose between curves. Now what it's going to do is ask you for first curve, second curve, and your best guess. If there's two curves, it doesn't matter which curve you pick first, but if you had a few different graphs on there, you might want to be careful. So first curve, I'll press enter. Okay, my cursor happens to be on the x squared cosine x natural log of x. Fine, I press enter there. And the second curve, you could see it goes on the only other curve, which is the line y equals 5. And I press enter. All right, the next thing it asks you to do is guess. Now, let's say so I find myself on this line, which is kind of lucky, but if you happen to pick as the second curve this x squared cosine x natural log of x, if you press to the left and right, sometimes you wouldn't even know exactly where this blinking cursor was on the graph. So yes, I can use the arrows to get to the intersection point. But remember what we talked about in the last video, you could actually just press the x value. So if I want to find this intersection point, sure, it's going to get me this intersection point because I'm close there. But you also notice, look, remember our x scale is 1, so 1, 2, 3, 4, 5. It's pretty close to 5. So if you press 5, the calculator is going to know you want this intersection point and not this one because it's closer to that. Now if I press enter, you see the intersection is 4.8475966, so that's a solution. Okay, that x, the y is 5, and what that's telling you is both sides of the equation equals 5, which is okay, could be interesting information. But what we really wanted was, what is the x value that's a solution to that equation? So that ends up being your answer there. That, and also, like I said, this x value as well, which I'll leave it to you to figure that out. The other way you could solve this is by using zeros. So what I'm going to do is I'm going to go to y equals, okay? I am going to just get rid of this second graph, just clear that away so we don't have it. And like I said, like I showed you before, if I subtracted 5 from both sides, I would get 0 equals, well, this expression here. So if I graph this expression and find the zeros, that should be a solution as well. So same deal, I'm going to graph this minus 5. And like I said, this is really the way I like to solve equations of this sort. It's less confusing, that you don't have multiple graphs on the screen. It's just easier. Another point I want to bring up here is you notice it doesn't really have the full picture of the graph. Honestly, that doesn't really matter to us because all we care about is where does the graph cross the x-axis in the in the domain, to be official, of values of x between 1 and 8, not including 1 and 8. So this just to show you that it's the same thing, this x coordinate here is going to be exactly the one we found for the intersection point. So I go to second calc, I go to 0, I press enter. Left bound, this is a perfect example. Okay, we happen to see the cursor, but it was kind of down here, and sometimes it can get confusing figuring out where it is. Well, that's when you could see, all right, I know the 0 is in between 4 and 6, and that's playing it safe, So left bound, I could press 4 and enter. Right bound, I could press 6 and enter. And guess, because there's 1 0, I don't even have to think about that. If you had to think about it, around 5 it looks like. And I press enter, and look, right away you get one of the solutions to the equation. You could do the same thing with this 0 over here to get the two different solutions. Okay, so that concludes this graphing calculator exercise. These are some of the main things that you really have to be able to use your graphing calculator for throughout the course. So hopefully this helps, and if you have any more questions, you know where to find me. I'm happy to help.